Good day, grade 10s. We are studying to learn about transverse waves, but in order to learn about transverse waves, we need to learn about pulses. A pulse is a single disturbance that moves through a medium, right? Okay, but what is a medium? A medium is a material or substance through which the pulse moves. Let's look at a little demo that shows us how this works. So if you have a look here, we've got this little thing. I'm going to put a little pulse on it and I am going to make it pulse. So do you see that every time this pushes up, we have a single pulse that moves along the medium. In this case, the medium is a rope made up of little balls. The reason being is they want to show you how the wave works or the pulse works. Okay, if I had to oscillate it, you would see that we'd end up with a whole bunch of pulses, which then in turn cause what we will eventually call a wave. But at the moment, we are talking about just a pulse, which is a single disturbance in the medium. So the hump made in the slinky spring is called the transverse pulse. So that hump there is called a transverse pulse. And note that the disturbance is at right angles to the direction of the motion. The motion of the wave is this way, but the pulse is going up and down. And that causes a transverse wave. But what is a transverse wave? When all the particles disturbed by the pulse move at right angles to the direction of pulse, then we end up with a transverse wave. Now we have a couple of rules and definitions that you need to learn. Well, just definitions. First of all, the distance from the zero disturbance to the maximum height of the pulse is called the amplitude. So let's try again. The distance from the zero disturbance to the maximum height is called the amplitude of your pulse. From A to B is the length of the pulse, called the pulse length. So, and that is all you need to know about pulses at the moment. I hope that helps you and it's a good start to moving on and learning more about transverse waves. Thanks, grade 10s.